In this module, we'll cover the operational challenges that every enterprise faces when going to the public cloud, whether it's single or multi-cloud. And then we'll take a closer look at how the Aviatrix platform can help solve those challenges. First and foremost, in the cloud, if something breaks, you don't have any proof or evidential data where the fault is. Each CSP has come out with statements such as, it's a shared responsibility, and that usually translates to you, the customer. Second, none of the CSPs have the network engineer's toolkit. And by that, what we mean is that none of them provide you with ICMP-based troubleshooting tools like ping or traceroute, or tools like packet capture or NetFlow. These are the tools that network engineers are used to from troubleshooting on-prem networks. Moving to the public cloud shouldn't mean that those tools are non-essential. On the contrary, they are more relevant than ever. Now, some CSPs have come up with proprietary tools like flow logs, which don't interoperate with traffic in other networks. They don't provide visibility there. And always remember that it's not in the CSP's interest to make life in multi-cloud any easier. They want you locked into their platform. That leads to the third point, which is that they are a black box. As we've said a few times over in this training, the underlying networking is abstracted. In other words, it is hidden from the end user. Regarding infrastructure as code, one of the main drivers for any enterprise to get into the public cloud is the agility that infrastructure as code offers. So you may be an expert in CloudFormation if you're in AWS, or Azure Resource Manager if you're in Azure, or Deployment Manager if you're in GCP. But the moment your company takes the plunge towards multi-cloud, and we at Aviatrix believe that it's just a matter of when, not if, then your infrastructure engineers have to undertake a lot of retooling. They need to learn infrastructure as code for a new cloud. It would be so much simpler with a cloud-agnostic approach to IAC, and fortunately there is, and that answer is Terraform. The world in public cloud is flat, and what we mean by that is that there is no hierarchy like there is in the on-prem world. There's no clear physical separation of elements and constructs. So there's really no clear guidance to operationalize service insertion and service chaining to meet the requirements of security and compliance. Then you don't want your tier 3 to become tier 1 for every routine matter. In other words, you don't want your designers and builders and architects to be roped into every single support or troubleshooting issue. And that's why we say that a multi-cloud network architecture must be built around the needs of an operations team and not the other way around. And finally, the more you scale out, the more difficult it becomes to operate your environment. And as we've seen, the CSPs provide basic networking tools that might meet the needs of a small proof of concept, but once you scale, it becomes unmanageable. When you're working with CSP native constructs, you need deep expertise to work with each CSP, whether that's AWS Console, Azure Portal, GCP Console, or their infrastructure as code offerings, which we talked about on the previous slide. Aviatrix provides a single pane of glass to deploy and operate your multi-cloud network with the network toolkit you already use in the on-prem world. And that single pane of glass is Copilot. Before we get into how the Aviatrix platform can help solve operational challenges, it's important to understand some context on the platform components. On the left, the controller has been through many years of software releases and is the interface for making any change in your cloud network. On the right, Copilot, which was launched in mid-2020, it's the day 2 operations component of the platform. It's designed to provide deep visibility and troubleshooting tools with operations teams in mind. We are not only multi-cloud, but also multi-account. What that means is that you can bring on multiple accounts or subscriptions or tenancies or projects for each cloud and onboard them onto the Aviatrix platform. We frequently encounter customers who have a single account per VPC or VNet. So for us, it's only a simple one-time action of onboarding those accounts. So the controller serves as a single pane of glass for all your cloud resources, regardless of how many cloud accounts you have. You can perform periodic audits to ensure that the privileges needed by the controller to access those accounts are in check. And if they're off, then we notify you. The VPC tracker tool is extremely useful for when you're managing environments in several accounts in multiple clouds. Because sometimes when you're managing those VPCs or VNets or VCNs, you lose track of all the CIDRs and subnets that you're using. So this is another single pane of glass to help you maintain that. But we can also go in and tell you if you're planning to create a VPC or VNet with a CIDR block that is overlapping with something that's already in your environment. Because sooner or later, you will run into overlapping IP address range scenarios. It's quite inevitable. Just about all of our customers have encountered this dilemma. So having a tool like this VPC tracker is great to avoid those situations. Another super important topic is controller high availability. Well, first of all, it's important to remember that the controller is in the control plane, as we've mentioned several times during this training. It's in the control plane. It's not in the data plane. And since it's not in the data plane, any outage of the controller has no impact on traffic whatsoever. The gateways are the ones in the data plane, not the controller. We achieve high availability by using cloud-native technologies such as elasticity and object-based storage. So, for example, in AWS, we make use of an auto-scaling group with a desired capacity of 1. The configuration of the controller in AWS is backed up to an S3 bucket. If the controller were to go down for any reason, a simple notification service or SNS alert would automatically trigger a Lambda script that would retrieve the configuration of the controller from that S3 bucket and rebuild a new controller with the existing Elastic IP. The SNS and Lambda scripts are configured and executed automatically, so the bring up of the new controller is also automatic. And we have similar methods for controllers in other CSPs as well. Infrastructure as code can be provisioned on the platform using Terraform. If you're not already familiar with Terraform, it's a cloud-agnostic approach to automating the deployment of infrastructure in the cloud so that you can build in a repeatable and deterministic fashion at scale. All the major CSPs are official Terraform providers, and so too is Aviatrix. This means that you can deploy your multi-cloud environment using the Aviatrix Terraform provider. And remember, Aviatrix has a dedicated ACE track on infrastructure as code in which we demystify terms such as DevOps and VCS, and we walk you through CI/CD pipelines with hands-on labs. The Aviatrix Terraform provider is always at feature parity with the UI. What that means is that anything you can do from the controller UI, you can also do via Terraform. We also provide several Terraform modules that build out transit spoke architectures in all clouds. These modules are like software libraries that offer cookie-cutter designs. In other words, they provide repeatability so that you deploy your environment in a predictable manner with even fewer lines of code. One of the easiest ways to write your Terraform code is to simply build it out over the UI and then export it to Terraform. There's a feature on the controller that will take care of this for you. In this demo, we're going to troubleshoot HTTP traffic between a client in GCP and a web server in AWS. The private IP of the server in AWS is shown here as 10.0.20.40. Let's hop over to this client and try a curl command, which will try accessing the server on TCP port 80. And the command fails, but as you can see, there is IP connectivity as shown by this ping command, just not TCP port 80. Now let's jump back into Copilot and take a look at AppIQ. We'll pick this front-end client in GCP as the source and this front-end web server in AWS as the destination. And we'll pick TCP as the protocol and port 80 on the private interface to perform the end-to-end test. The first thing to note is that in the top right corner is a link to PDF the entire output as a report that serves as a snapshot in time. Now, the first output shown is of the end-to-end path with latencies at each hop. This is extremely useful because just at a glance, you can see whether you're incurring higher latency than expected. For example, GCP US Central 1 is in Iowa and AWS US East 1 is in North Virginia. A latency of up to 30 milliseconds is expected. But if you had seen an outlier latency, such as, say, 70 milliseconds, then you would know immediately that there is something wrong between those two regions, perhaps on the gateways. Let's take a closer look at those gateways. Here, we see useful telemetry data in the past hour, such as free memory, bandwidth ingress limit exceeded, and packets dropped while sending or receiving. After that, there's flow IQ data for bandwidth usage at the source, at the destination, and from the source to the destination, all for the past hour. And finally, there's the flight path result. Here we see results of the VPC route table in GCP, the firewall rules in GCP, the spoke gateway route table, the transit gateway route table, the NACL in AWS, the VPC route table in AWS, and the security group in AWS for the instance. And here we see that it failed because HTTP was not allowed. So let's go in and edit that directly. Now, in a production environment, you probably wouldn't change this on the fly, but we'll make an exception for demonstration purposes. We'll just create a new security group rule allowing TCP/80 access. Also, in a production environment, you wouldn't be allowing access from anywhere on the internet. Again, this is just for demo purposes. Let's go back and rerun AppIQ. This time, if we scroll to the bottom, we see that the security group rule is now in place. Now let's go back to the client and rerun our curl command. And here we see that the curl command has now succeeded. Now I want to show you the Network Engineer's Toolkit on the Aviatrix platform. These are tools that many of you are familiar with when troubleshooting on-prem networks. We'll go over ICMP-based tools such as ping, traceroute, and tracepath, TCP and UDP connectivity tools, and packet capture. And separately, the UI walkthrough module section on Copilot Flow IQ covers the use of NetFlow for visibility. Let's dive in with an example. From Copilot Topology View, let's pick a spoke gateway that's in the same subnet as a workload of interest. Let's click this GCP spoke gateway. From the diag button, let's first ping the Google DNS server. Next, let's perform a trace route to a workload in our Azure environment that's 192.168.20.36. We can also do a trace path, which returns the largest packet size, or MTU, that can be sent over the network. Next, let's hop over to test connectivity on different protocols to this Azure host. First, let's try TCP/80, and that returned successfully. How about UDP 514 or syslog? Is the host running that? No, it's not. Finally, let's check out packet capture. We'll run a TCP dump on TCP/80 to the same Azure host and let it run for 10 seconds. Then, from the workload in GCP, we issue an HTTP GET to this Azure web server. And what we get back is header level information of the packets captured. We can go into more details and get payload information by downloading a PCAP file and viewing it in a tool such as Wireshark. In this particular scenario, I'm going to make use of the topology replay function. The way this scenario presents itself is that I have a site to cloud connection, and it is connected to a partner site. The partner site has a router. The router was rebooted recently. And as a result of that rebooting, we received two emails. The first one is saying that the site to cloud connection called Cisco branch went down, went from up to down, and the transit gateway that was affected was this one here, which is highlighted. That was at 9:59 a.m. About 4 minutes later at 10:03 a.m., that particular site to cloud connection came back up. This was really the result of a router at the remote partner site being rebooted. Now, let's say you don't have access to email for whatever reason, or you need a different way of being notified. This is a different way of being notified. This is Slack. In Slack, you can set up webhooks. So in this case, Copilot was configured to set up to generate webhooks, which is basically JSON payloads. And those alerts were sent to the app. In this case, the app was generated for Slack. And so on Slack, the app was installed, and it's listening to on this channel called Umair-Copilot. The way to interpret this is that the above notification sent today at 10 o'clock is basically saying that the status is open. What happened was that the Cisco branch connection failed. Then 4 minutes or 3 minutes later, that same alert was closed. And what we mean by closed versus open alert means when there's an issue, when there's an outage, when the tunnel goes down, then the alert is in open status. When the issue goes away, either manually resolved or just the gateway, the remote router came back up, the issue is now enclosed. So this is another way of being notified through a webhook. This webhook is actually generated in Copilot over here through notifications. You can see here that there was a status that came up at 10 a.m. today. And it basically says that the Cisco branch went down. It had a BGP connection. And at that point, the alert was an open status. That was when it was newly created. And then 3 minutes later, the alert was closed. And that's because the host auto-recovered. The remote site came back up. Now let's take a look at how this looks like in a very cool feature called topology replay. So topology replay is something you can think of as your DVR, your digital video replay. What it does is it keeps track of all your changes in your environment. So the way to interpret this is that if we look at the most recent change here, it says that the route, in fact, we can do a search of this partner site. And if we go back in time, we can see that at 10:01 a.m., the router at the partner site was rebooted. And this is what it actually looked like, this particular entry. We went into the router at the remote site and we issued a reload. And when that reload took place, the next thing that happened was that the BGP routes were no longer advertised. And as a result of that, these 3 routes went away. Next, 2 minutes later, the router at the partner site came back up. And then finally, the routes from the partner site fully propagated throughout the network. And that's when all 3 of these routes were fully propagated throughout the network. That's just one example of how topology replay can be used. It keeps track of every single change in the environment. Now that you have a fair idea of what Aviatrix is all about, it's time to lab it up. How can you build a multi-cloud network architecture easily, quickly, and at a low cost? The answer lies with the Aviatrix Sandbox Starter Tool. The Sandbox Starter Tool, or SST, offers a fast path to deploying a multi-cloud transit at a very low cost. It's a turnkey solution to deploy a controller in AWS, a transit in AWS, and a transit in Azure, along with some test instances. You can deploy Sandbox Starter Tool in a Docker container, either in the cloud or locally on your laptop. You can also deploy it from an AMI in AWS, that's in US East 1 region, or you can build it in other regions using a Terraform module. The Sandbox Starter Tool is a very modular tool. You could build just the controller and stop right there at a cost of just 9 cents an hour, or you could test the functionality of a transit spoke architecture in AWS for a few cents more. You also have the choice of building into Azure. It's completely up to you. SST will build a controller in AWS. You can pick either the pay-as-you-go or metered licensing model, or you can bring your own license. The automation will take care of many configuration steps for you, such as the creation of VPCs, security groups, and account onboarding. If you build a transit in AWS, it will create 1 transit VPC and 2 spoke VPCs. In each VPC, there is an Aviatrix gateway, and there are tunnels attaching the spoke gateways to the transit gateway. You can optionally build a couple of test instances in the AWS spokes. If you choose to additionally build in Azure, it will create 1 transit VNet and 2 spoke VNets. And in each VNet, there is an Aviatrix gateway, and there are tunnels attaching the spoke gateways to the transit gateway. You also have the choice of peering the 2 transits. Now, there are 2 modes to Sandbox Starter Tool, Standard and Advanced. In Standard, the regions, resource names, and CIDR blocks are all picked for you. In the Advanced mode, you can customize any of those. When you start the SST wizard, the first thing you need to do is input your AWS credentials for programmatic access. The documentation provides guidelines on minimum IAM permissions to comply with the least privileges principle. And when you're done, if you've chosen to build everything, including the test instances in the AWS spokes, you'll be shown their public and private IPs, and you'll be given the public IP of the controller. Now let's see this in action, starting with the documentation. Just visit community.aviatrix.com and search for Sandbox Starter Tool if you don't already have the URL handy. In this demo, we're going to launch the Sandbox Starter Tool using the AMI. This AMI is in AWS US East 1, which is in North Virginia. We give the instance a name, we select a T2 micro instance size, we pick a key pair in US East 1, and we create a new security group that allows HTTPS access. And to make it more secure, we highly recommend not allowing access from anywhere on the internet. Instead, after we give the security group a name, we highly recommend restricting access to only your IP address. The rest of the defaults are fine, and we can launch the instance. I'm going to pause the video now and return after the Sandbox Starter Tool instance has started. Okay, it has started. Now we can access it. At the top, the version of the Sandbox Starter Tool is displayed. Always refer to this version when you're troubleshooting and are contacting the community or reaching out to Aviatrix. The first thing we need to do is specify our AWS Access Key ID and Secure Access Key. And these can be generated from the AWS console under IAM. Next, we enter the email address for the controller's password recovery. And then we set a password. This password is for the admin user. Now, since we're running this in advanced mode, let's put this controller in Singapore instead of North Virginia. This means we're going to use the region AP Southeast 1 instead of US East 1. We can select what controller version we want to build, and we can select the license type, either metered or pay-as-you-go, or BYOL, or bring your own license. I'm going to keep the defaults here and click Continue. And at any time, you can click the blue Debug button in the bottom right corner to get more information and more details. This process of building, customizing, and upgrading the controller takes a few minutes. I'm going to pause the video and return when it's completed. All right, we're back. The next step in the wizard is whether we want to build a transit in AWS. I'm going to say yes, and I'm going to change the region from the default of US East 2 or Ohio to AP Southeast 1 or Singapore. Again, I'm going to pause the video and return when the AWS transit has built out. We're back, and the AWS transit has launched successfully. Now we're asked whether we want to build a couple of test instances in those AWS spokes. I'm going to say yes to that. And we need to make sure that we have a valid key pair in the region where the spokes are, which again is in Singapore in this case. Enter the name and import it. Again, I'm going to pause the video. Once the test instances have built, we have the choice to build a transit in Azure. In order to do this, we will need to supply the 4 API keys for programmatic access. That's the subscription ID, the directory ID, the client ID or application ID, and the client secret or application key. And we'll keep the Azure transit in the default region, which is East US. The final optional configuration step is to peer the two transits, AWS and Azure. Let's go ahead with that, pause the video, and return when it's done. All right, we have successfully peered the AWS and Azure transits. And we're done with building everything from the Sandbox Starter tool. Now let's explore what we built. The first IP is that of our new controller. It has a self-signed certificate, so we can ignore these warning messages and proceed. We'll log in with the admin username and the password that we set during the installation wizard. When we first log into the controller, we're given a tip of how to deploy Copilot from this controller. Let's dismiss the other tips and take a moment to see what we built. We onboarded an AWS account and Azure account. We built 2 AWS spoke gateways and a transit gateway, making it a total of 3 in AWS. We also built 2 Azure spoke gateways and a transit gateway, making it a total of 3 in Azure. Each spoke is attached to the transit in its own cloud, and the 2 transits are peered together. We can see where on the map these transits and spokes are. AWS is in Singapore, Azure is in East US. And we can verify this by viewing the list of gateways as well as the list of transit and spoke gateways. Now let's try a data path test to verify the routing. We'll go back into the Sandbox Starter tool and copy the public IP of one of those test instances. Then we'll SSH to it. Remember, we must have access to that key pair whose name we specified in the Sandbox Starter tool wizard. Next, we take the private IP of the test VM in the other spoke and try pinging it. And we have success. Feel free to play around and run other tests as you like. When you're done operating with the Sandbox Starter tool, be sure to tear it down to avoid unnecessary costs. To do so, just click this Destroy button in the top right corner. This will tear down everything that the Sandbox Starter tool built, including the controller. When it's done destroying, you'll get a screen like this. And that's the Aviatrix Sandbox Starter Tool.